This video will continue the economic order quantity example that began in the previous video by introducing the assumptions to the model. So in the economic order quantity model, the decision variable is going to be the order quantity that we use in each order cycle. In this case, we're going to use the solver tool to go ahead and find the order quantity. So all I'm going to enter right now is simply a starting value, maybe something like 1,000. All of these other lines under the decision variables section we'll use when we build other models. But for right now, we just enter the order quantity. Now what we'll do is enter the cost. So in the economic order quantity model, we have an assumption, in this case, that it takes $5 as a fixed ordering cost, regardless of the order size, every time we want to order. We're going to order 26,233 annually, and so the number of orders per year is just simply going to be the annual demand divided by the order quantity, and the order quantity may change when we use solver. And then the number of orders per year is going to be multiplied by the fixed ordering cost, and that will give us our total annual ordering cost. Our holding cost is going to be based on our average inventory. And so in the economic order quantity model, we assume that the maximum inventory level is going to be Q, and the maximum inventory occurs right after each order arrives. We'll draw that down to 0, so the average would really be halfway in the middle of the order quantity and 0, or 0.5 times the order quantity. And so then the holding cost is going to be the average inventory times the holding cost per unit per year. Now, there's several lines in here in the cost section that we aren't using right now, but we will as we factor in safety stock to our model. And additionally, we're not considering the shortage cost right now. So our annual inventory cost will simply be the annual ordering cost plus the annual holding cost. We are going to enter the cycle time because we're interested in that cycle time, which is the time between orders. What we need to do is go up here and think about what would be our daily demand. And if the average annual demand is 26,233, and we're assuming for this company they work 300 days a year, then we can just calculate the mean or average daily demand as the annual demand divided by the working days, which is about 87. So the cycle time is the number of days it takes to use up one order worth of inventory. And so the cycle time is going to be the order quantity divided by the daily demand. Now we need to minimize costs. So in the economic order quantity model, we get to choose the order quantity that will minimize the total annual inventory cost. So we can do that with solver. Go up to the data menu and select solver. And so our objective is to minimize the total annual inventory cost. We check minimize. The changing variable cell is the decision variable, which is order quantity. And the only constraint we have is that the order quantity can't be 0 or negative. So what we'll do, just to ensure this, is enter a constraint. And in the left-hand side of the constraint, we'll click on the cell for Q. change the sign to greater than or equal, and we'll put 1. That'll make the order quantity at least 1, and so it just causes it to not go negative and create errors in the model. And so that would be our solver setup, and then we can solve. And so what we see here is that it has selected an order quantity of 464. Our cycle time, the time between orders, is going to be 5.3 days. And our total inventory cost is 564.79. One important thing we notice here is that the annual ordering cost is exactly the same as the annual holding cost. And if we click over on the EOQ graph, we'll see this. We see that the orange line is the ordering cost, the blue line is the holding cost, and they cross right here, which is right about 464, and where the costs are somewhere in between 2 and 400. In fact, right about 282. The gray line is simply the blue and the orange added together, and so we see that right about where these lines cross, we're just a little bit below 600. And here we see that the total inventory cost is 564 or 564.79. So the model here matches the picture.